So for this one here, we should really have a sense of whether this converges or not. Okay, and this numerator is going to bounce between -1 and 1, and this denominator is going to be a p series where p is equal to 2, and we know that that p series does converge. So what's going to happen here? Well, we can just do this comparison. We can say that the cosn, the absolute value of it, some of them are positive, some of them are negative. So together, they must be less than 1. And the absolute value for that matter is actually less than or equal to 1. So the absolute value is going to be less than or equal to 1 over n squared. So we know that every one of these terms is going to be smaller than every one of these terms. In fact, since some of them are negative, it's going to be even smaller than that. Okay, so we can say that this must converge because we know that 1 over n squared is the basal series, and the basal series converges, so we must be able to conclude that that one also converges. So if we take a look at this, we can just say then that because this comparison, we can say that 1 over n squared from n equals 0 to infinity, it converges. Okay, in fact, we know what it's equal to, but that's not relevant. We know that that converges. Therefore, we can make the conclusion then that since the cosn over n squared is smaller, that must also converge. Okay, so by this comparison, we haven't done any real formal math here, but by comparison, we know that this also converges. Okay, so this is a comparison. We're just comparing one to the other. And in fact, we can graph this and we can see that this, although this is discrete, but when we look at the graphs, we can see that this is always lower than that.